Away. Let's roll it. Let's roll it. So we have number one. Cool. So the first term in a almost a geographic. The first term in a geometric series is 14. So this is what you know. In fact, let me use red. This is what you know. A geometric series. No. A geometric sequence follows this rule that you have a r to the power of n minus 1. Yeah? And the first term is a, right? Because t1 will just be a r and 1 minus 1, which is a r to the 0, which is a, right? Cool. And then the sixth term is 448. So that's the sixth term. You like t6 ar6 minus 1 ar5, right? So you guys are still following. Cool. Yeah, then the question, they like calculate the constant r, right? You know, r is that constant ratio which you multiply your terms by to get the next term, right? So yeah, so you can say we have focus on just these, ne? Not yet done. They said a, or the first term, is 14, and this term it's 448, right? So I'll write it clearly. It's a equals to 14, and then ar to the power of 5 equals to 448, right? So say that's 1, that's 2, sorry for that. And because from here we see a is 14, we can say therefore we've got 14 r to the power of 5 equals to 448. We divide by 14 both sides. We're going to get 448 by 14, 32, right? And then I think 32, I think it's 2 to the power of 5, yeah? So you have r to the power of 5 equals to 2 to the power of 5, therefore r equals to 2. You see? So we have found our constant ratio, which is, which is 2. Then determine the number of the consecutive terms, okay, that must be added to the first 6 terms of the series in order to obtain the sum of that much. Cool. So cool. Okay, so here it's clear we are talking about number 2, we are talking about Sn, right? But now you have to, okay, for geometric we have 3 formulas for the sums, né? The first one is sum. Let me say we have the sum to infinity, right? Which apparently, there's no way from this question we could have a sum to infinity. Can you guys guess the reason why? Our r is greater than 1, right? Remember, if your r is between -1 and 1, then you have a convergence series, and therefore there is a sum to infinity. But here there isn't, right? So that leaves us with 2 formulas. So there is one formula we use when we have our r being smaller than 1, and we have one formula which we use if our r is greater than 1. So just make sure you know them. The formula we're going to use here, it's this one. This is the one we use if r is greater than 1, right? Cool stuffs. Yeah. So, but before we calculate, we need to understand the statement here, right? The statement is saying that there are consecutive terms, ne? They are consecutive terms that we added to the first 6 terms. Do you understand? So there are 6 terms: term 1, term 2, term 3, term 4, and term 5, and term 6. These are our first terms, our first 6 terms. Ne? And then from our first 6 terms, we add a couple of consecutive terms, right? Of which now when we find the sum of all these terms, the ones we added plus the 6, we get a total of this much, right? So what we can do is we can find out how many terms gives us this sum, right? How many terms are going to give us that sum? So we go to our formula. We're going to substitute Sn as 114,674. Cool. So it's 114,674. Is that cool? 114,674. Cool stuff. Our A, what is A? By 14. R, we have, oh my word, 2. Yeah, because of course we know R is 2, right? Cool stuff. Let me just check. 114,674. Just checking if it's divisible by 14. Beautiful, it is. So 114,674, 14, because the 2, this the minus, and it's 1, and yeah, 2n minus 1, right? Then I divide by 14, 2n minus 1. One, 114,674. Come on. Right, and then this one goes that side, yeah. So yeah, this one is gonna go to that side. What is the one? It is minus plus. $8,192, right? Yeah. So I mean, there's a big number, right? And fortunately, you guys in grade 12, you're going to learn. Yeah. So I don't know the order in which like you guys are following, right? It might be different from my order, but if you have already done logarithmic rules, right, you would know that from here you can just say n equals to, right, log 2 and then 8192, right, which is a, so where is that one? So this is nice, 28192, right, which is exactly 13, right? This is of course if you've done the log rules. Yeah, I don't know. Okay. Okay, so I'm gonna do this now. There's a video I'm going to make under functions, right? Under functions, we're going to talk about logarithmic rules, especially when we get to, because they're important when you deal with what is this? When you are dealing with exponential functions, you're going to use logarithmic rules a lot, right? Because you have an x as an exponent, and you might have to solve for x. Do you understand? Especially when you're looking for x-intercepts whatsoever. Right? So you're gonna use log rules a lot. So for now, I will say here's a easy trick. There's a trick that I've forgotten. I'm gonna talk to my younger brother to show me how it's done, and I'll make a video to show you guys how it's done. But I'm sure most of you know how to do it. Now, my trick if it happens that I've forgotten anything or any trick about how to solve this problem when I'm here, I take 2, I raise it to a couple of numbers, 8, it's still below, right? 10, 1,000, let me see, 11, 12, wow, 13, look at that. You see, you can, same number you started from 20, you're like, that's a lot, let me go 15, Jesus, 12, oh, that's a little, so you go 13, it is. So it's yeah, it's I don't know. And of course, if you happen to have chosen this way, you would then have 8192 equals to 2 to the power of n, and then you would say 2 to the power of 13 equals to 2 to the power of n, therefore 13 equals to n. Bro, you're not gonna lose any mark here, man. You're not gonna lose any mark. You're gonna get 100% of this question right. Even if you did do that, inspection thing on your calculator, bro, you're not gonna lose a mark. So this is what I used to do when it was yeah, because I remember there were multiple times when I forgot to do that nice shortcut with a calculator. You press a number and it gives you the number back, but in its simplified exponential form. Yeah, so we haven't answered the question. 13 is the total number of terms that gives us this much, right? So that is 13 is the total number of terms, and that gives us this much, right? And now remember, we have the first 6 terms and other consecutive terms. Together, those terms, they give us 114,000. So you are going to say the answer we're looking for is x, which was added to the first 6 terms. X many terms were added to the first 6 terms, and they gave us 114k, and those terms in total, there were 13 of them. So therefore x will be 13 minus 6, which is 7, I believe. Yes, it is, right? So yeah, so your answer, it will be after 6 terms, you would say 7. There were 7 consecutive terms that were added that were added to the first 6 terms of the series in order to obtain that sum over there. You understand? Cool stuffs. Clear some space. What dude, come on, bro. So this guy is also having attitude. Cool. So the third question, it says if the first term, so now it's vice versa. You see, the first term of the series is 4, 4, 8. So this term is now 4, 4, 8, and the 6th term is 14, right? So now we have to find the sum to infinity, right? And look, the first thing is, one thing that will confirm that you are still doing the right work, like you haven't made a mistake on your analysis. When you are asked to calculate the sum to infinity and your r is actually between -1 and 1, just know you are doing the right work. Just make sure you don't do any silly mistakes. Other than that, everything is fine. So we're gonna test, we're gonna calculate our R here. So you have A equals to 448, and then AR to power 5 equals to 14. When you substitute, you'd say therefore 448 equals to yes equals to no, I forgot something, man, which is r to the power 5. So this is A, and then this is right, then we have equals to 14. Then you divide by 448 both sides, so you have r to the power 5 1448, right? So 14 by 448, you are getting 1/32, right? R to the power 5, which you would know. Remember, 2 to the power 5 was 32, right? That will mean R to the power 5 is equals to, you have half to the power of 5. And since the exponents are the same, therefore R equals to half. And we know we are right, we know we are doing the right thing, because our R is between -1 and 1, right? So cool. And when you're calculating sum to infinity, you only need the first term and R. So since we have those, we can just say first term is a 448, and then you have 1 minus 1/2, right? Calculator, 448, 1 minus 0.5, which is just 1/2. So you get your answer 896. Then you are done, bro. You are done. Let's see what this question, the last one, has for us. So they say that if that equals to that, determine K. We have to find what K is. Right, so let's talk. The value of K, ne? Let's talk. Here, okay. Try to hide, or try, let's imagine we don't have this, ne? We don't have this, and this bracket are gone, ne? You only have 1/3p plus 1/6. That right there is an arithmetic series. Man, not series, it's a sequence. Arithmetic series. It's an right there we have an arithmetic sequence, ne? Remember, it only becomes a series when we are adding all the terms. So yeah, you have an arithmetic sequence, ne? Now when we look at the whole thing, we have a sum of, so we have an arithmetic series, and we are finding the sum to get 21/6, right? But let me show you something. Whenever I'll do this, whenever we are calculating as sum to a particular number, we would say n 2a 2a plus 2a plus n minus 1d. This would be the formula we use now. And this formula, what it means, it's saying you are going to add from n equals to 1 to what? No, not n equals to 1. Yes, from n equals to 1 to okay, fine, to the last value. And I don't know, it doesn't make sense when I write it like this, but like, let me just say I here, ne? I equals to 1. So you're starting from 1 up until n, you are adding all these values. and then here you'd have your function, right? I'm guessing that will be 1 over 3p. Just make an example. I'm not saying, let's assume this is the function, that this is the general rule inside our summation sign. Sn, what I want to highlight is that we start from 1. Now this equation, if we use it and we make the substitution whatsoever, it is starting from 1, not 0. These guys, they started from 0, right? So let me show you something. Let me show you something. I'll give a very, very simple cool. I have Tn, right? Cool. Let's compare this, né? So Tn equals to 2x minus 1, né? Let's compare these two. Compare the sum to 10 from 1, 2x minus 1, né? versus the sum to 10 from 0, 2x minus 1, né? So we have the calculator. Let us use it. So you have 2, né? 2x minus 1. Let's start from 1. We're going up until 10. So for here we're getting 100, né? Let's start from 0. Let's see what we get. 99. Do you guys see? Yeah, so there's a difference between these things, and you have to be very careful. The formula Sn equals to, right? Say for example, it's S10, né? And then we have 10 divided by 2, and then we have 2 into a, right? Let me quickly find a. A is going to be 2 times 1 minus 1. A is 1, right? And then plus d is 2 into n, which is 10 minus 1, right? Here I have 5, né? Here I have 2. Here, okay, I'm gonna have 9 here. This is going to be 9 because 10, which is n minus 1 is 9. So then 9 multiplied by 2 is 18. So I have 18. Ne? So 5, 2 plus 18, 100. Ne? So with this, there's one key thing I want to address. This formula Sn is for the summations if we are starting from 1, not 0. Do you understand? Sure. This is how it is done. Yeah, one. So, and also I want to show you something. Very, very fast. I will use these two things, né? Delete. So now I want to write them manually, right? So 2 minus 1. I have 0. That's minus 1. 1. Cool. I'm seeing the pattern. 11, 13, 15, 17, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I might need some space. And so the in terms of the terms is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, we move from 0 up until 10, and then if we move from 1, we're gonna have exactly these. Copy, paste. Right, and then this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, so you see, so now if I count the numbers that are here, if I'm starting from 1 and I count the numbers that are here, how many numbers do I have? I have 10 numbers. And then here, if I count the numbers that I have, given that I start from 0, I have 11 numbers. It's 1 up until 10 plus this one, 11 numbers. So yeah, I'm trying to paint a picture. I'm trying to paint a picture here that is going to help you with this problem, like the thinking behind. And it's worth 5 marks. The rest are just child's play. This one is worth 5 marks. So yeah. Also, I want to show you something also. This is the last thing, then we attack the problem. I want to show you something. So you see this, I think this part, it's fine. You see this part, that part, I'm sure that you guys understand everything about it, yeah, you guys, I'm very, very sure. So I want to talk about this, and I want to show you something. So we have 11 numbers here, right? And this is number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 terms, and then say, for example, I say this, I say a equals to 1, No, I got confused by this. Let me get rid of them. A is minus 1, which is the first term, right? But then here, a is what? A is 1. Do you see? Cool. And then what else would I need? I need D, right? I need D, right? And D, to get D, I can just say, because I know this is arithmetic, I can just say T, any consecutive terms, T3 minus T2 should give me, right? So that is 3 minus 2 minus 1, that is 2. So D, that is D. So then so then I would say that Sn, or as how that will be S11 actually, if I go up, like if I count all the numbers in. Alright, so I'll have 11 over 2, then I would have 2 into minus 1 plus 2 into 11 minus 1. 11 over 2, 2 into minus 1 plus 2 into 11 minus 1. Right, I am getting the 99 that I got. And also now look at this. The formula for this can also be Tn equals to, so we have A plus n minus 1 D. A is minus 1, n minus 1, D is 2. Minus 1 plus 2n minus 2, right? And then we have, what do we have here? Okay, we have 2n minus 3. Cool. So yeah, this is what I wanted to show you. So did you see here we used the same formula, just that we started from different positions. Now we started from 1, we started from 0. But now if I change my formula of the pattern to this, given that now in this case I started from 1 being this term, you understand? Then in total I had 11 terms. In total I had 11 terms. Do you understand? So yeah, so if here I say I put k, right, you can then say perhaps n equals to k plus 1, right? And then here you would start from 1. Do you see it? Yeah, it's exactly the same thing. We had 10, right? But in terms of the number of terms that are there, we had 11 terms. And when we did count the numbers here, we have 11 numbers, and we use the SN formula. We get the exact same value we got when we use the summation on the calculator, which is 99. Remember, this one we got 100, this one we got 99. You see? Cool. So now we're going to talk about this question. How then are we going to attack it? So first thing first, you see you are starting from p equals to 0, right? You are starting from p equals to 0. So then I can say, okay, I can do this, say first term, t1, right? T1, you substitute p, which is 0. 1 over 3, 0 plus 1 over 6, and you get 1 over 6. All right? And of course, this is a. Yeah, well, then the second term, t2, that will be 1 over 3. We started from 0, we go to 1 over 6, right? So that's 1 over 3 plus 1 over 6. 1 over 3, we can write it also as 2 over 6, right? And then here you have how much? 3 over 6. Let me just see. 1 over 3 plus 1 over 6. Yes. Which is half. You see? So now, if I want to find d, I can say d equals to t2 minus t1, which is going to be half minus 1 over 6. So half, that is 3 over 6 minus 1 over 6, which is 2 over 6, which is 1 over 1 over 3. So d is my 1 over 3. And also, for arithmetic, when you've been given an arithmetic sequence, you don't have to calculate d, because it's the variable of the constant. No. It's the constant of the variable. Yes. Yeah, you don't have to calculate it because it's the constant of the variable. No, not the constant, bro. You see, that's the thing with maths terminology. The coefficient. The coefficient is the coefficient, bro. Jesus. So yeah, it's the coefficient that we're looking for, right? And there it is, 1 over 3, 1 over 3. So I want the next part is very important. Ne? It's very important because I don't know how to properly explain it. Ne? That's why I did the examples that I did before. Yeah, for it to make sense, you see. So here we can say n equals to what? We're going to equate n to something, right? Yeah. Remember the previous example, the one I used for illustration. Our summation, the last term was 10. We were adding one part, we were adding from 1 up until 10. The other we were adding from 0 up until 10. Let's focus on the one where we were adding from 0 up until 10. There where we were adding from 0 up until 10, when we use the SN formula, instead of substituting 10, we substituted 11. So we substituted 10 plus 1. And that 10 plus 1 here is what? Is going to be k plus 1. Right? That is what n is going to be. Right? So then that means if I use the formula of Sn, right? If I use the formula of Sn, I will not be wrong anyway, right? Because yeah, I will not be wrong anyway, because remember, you can't use that formula here and then the value you find, you then say that value is equals to k, because here we started from 0, right? If they started from 1, you could move from here straight to the Sn formula. So yeah, n to right, you have 20, 1 over 6, you have k plus 1 divided by 2 into 1 over 6 plus 1 over 3, and remember n is k plus 1 minus 1, right? Then 20, 1 over 6, that is 121 over 6 equals to k plus 1 over 2. I have 2 over 6 plus, here it's going to be 0. 1 minus 1 is 0, so I have 1 over, or let me just say k. Right? Then let me multiply the whole thing by what? By 6. Ne? If I do that, 6, 6, 1, 2, 1. And then here I'm going to have 3 into k plus 1. Right? And then, well, let me before I do that, 121 divided by 6, k plus 1. Cool. So I have 2 k plus 1 over 2 times 6 plus k plus 1 over that is going to be 6. 2 times 3. Let me verify. This went down as it is. 2 times that. Yes. K times that one. Cool. Everything is still fine. Now I simplify. 1, 2, 1. This they cancel, so I have k plus 1 over 6. I have k squared plus k over 6. So now when I multiply by 6, I have 1 to 1 k plus 1 plus k squared plus k. And therefore, let me say I have 0. That will be k squared plus 2k plus 1 minus 1, 21 k squared 2k. Yeah, this is just pap and milk. I think here we can have our 2 brackets. Find two numbers, you multiply, you get 120, divide or subtract, whatever, you get 2. I'm thinking 10 and 12. Right. Twelve has to be positive. K will be negative 0, 0, right? And then we can say therefore k equals to minus 12 or k equals to 10, right? So from here we have a k that is negative and a k that is we have a k that is positive and a k that is negative. So now which value makes sense of k? Which value of k makes sense? I'm just gonna copy the k's, copy, paste them somewhere here with some nice coloring. Black is fine. That's not even black. Maybe it is. But yeah, so the question that I have now is which k makes sense? Now we have 1k being 12, minus 12, minus 12, and another k being what? Being, we have a minus and we have a positive. Right? I don't care much about the numbers. I only care about the signs right now. Which one makes sense? You look at the question, or you don't even have to look at the question. The thing is, your sigma, not sigma, yeah, it is sigma, your sigma notation, right? Your sigma notation, it says this is the upper bounds, this is the lower bounds, right? So that means when you write your values, this is the lowest, right, where you are starting from, right? And this is the highest you would go. And if k was minus 12, if it was minus 12, then we would have had something like this, 0 and minus 12. This makes sense, right? What doesn't make sense is having 0 and having a negative 12. It's not like that, you see. So yeah, we move, this is the lower bound and this is the upper bound. So that means the only k that makes sense is k being equals to 10. You understand? K being equals to 10. So yeah, so it was a bit tricky question, right? It was a bit tricky question, but I hope that the illustration that we did, I hope those illustration, they will really help in you being able to attack such problems in the future. Yeah, cool. So let me end it here. Let me end it here. And this is the last video for the whole chapter. So that being said, I will see you guys in the next chapter.